Two men stand above all others in the history of physics. Sir Isaac Newton, the father of classical mechanics. Albert Einstein, the architect of modern physics. Newton laid the groundwork that made science precise. Einstein tore open reality and showed us the unseen layers beneath. But when we ask, who changed physics more? We're not just asking about discoveries. We're asking about how we understand everything. Today, we explore their lives, their theories, their influence, and the profound mark each left on the universe. This is history's greatest minds. Hit that subscribe button. The journey begins now. Born on Christmas Day, 1643, in Lincolnshire, England, Isaac Newton arrived prematurely. Small, sickly, and not expected to survive. But survive he did. And in time, he would shape the world like no one before him. Newton entered Trinity College, Cambridge, in 1661. But in 1665, the plague swept through England, closing the university. Newton returned home. What followed was a period of isolation and brilliance. In the span of 2 years, Newton formulated the foundational laws of motion, created a new theory of gravity, developed calculus, and began groundbreaking work on optics. This period is known as Newton's Annus Mirabilis, his miraculous year. Newton's first law, inertia. Objects remain at rest or move in a straight line unless acted on. The second, force equals mass times acceleration. F equals ma. The third, for every action, there is an equal and opposite reaction. These weren't just observations. They were universal principles. Predictive, testable, precise. Newton postulated that every mass attracts every other mass. The same force that pulls an apple to the ground governs the orbit of the moon. This was radical. Until Newton, the heavens and earth were considered separate realms. He unified them. To describe motion under gravity, Newton invented calculus. Independently of Leibniz, he laid the mathematical groundwork for change over time. In optics, he passed light through prisms, proving white light was composed of colors. He even built the first functional reflecting telescope. Newton's Principia Mathematica, published in 1687, is one of the most influential books in history. It shaped the Enlightenment. It launched centuries of engineering. Newton gave humanity the blueprint for understanding the physical world. A world that seemed perfectly ordered. For 200 years, Newtonian physics reigned unchallenged. It explained falling apples and planetary orbits, cannonballs and comets. Engineers built machines. Scientists predicted eclipses. The universe was a grand machine, and Newton had shown us the gears. But cracks began to form. Light, everyone believed, was a wave. Waves travel through a medium. Sound needs air. Ocean waves need water. So what did light travel through? Scientists proposed a mysterious substance, the luminiferous ether, that filled space. But no one could detect it. This legendary experiment tried to measure Earth's movement through the ether. The result? Nothing. Light speed appeared constant, no matter the observer's motion. This baffled physicists. It directly contradicted Newtonian expectations. Another problem. Mercury's orbit didn't behave as Newton predicted. Its perihelion, the point closest to the Sun, drifted over time. Newton's laws couldn't explain it. Something deeper was happening. And into that mystery stepped a mind unlike any the world had ever seen. Albert Einstein was born in 1879 in Ulm, Germany. As a child, he was quiet, reflective. fascinated by compasses and light. He once said, "The most beautiful experience we can have is the mysterious." In 1905, while working as a clerk at the Swiss Patent Office, Einstein published 4 papers. They would change the world. Einstein proposed that light came in packets, quanta. This explained why shining certain frequencies of light on metal caused electrons to be ejected. It wasn't about intensity. It was about energy per photon. This won him the Nobel Prize and launched quantum physics. What if the speed of light was constant for all observers? That's the question Einstein asked. The result: time and space must change instead. Time dilates. Moving clocks tick slower. Length contracts. Simultaneity becomes relative. Then, he gave us the most famous equation in history. E equals mc squared. Mass is just a form of energy. Einstein realized that gravity isn't a force. It's the warping of spacetime by mass and energy. Earth orbits the sun because the sun bends spacetime. This theory predicted gravitational lensing, black holes, and time dilation near massive bodies. British astronomer Arthur Eddington measured starlight bending around the sun during an eclipse. Just as Einstein predicted, newspapers declared revolution in science. Einstein became a global icon overnight. Newton believed in a clockwork universe, a God who wound up the cosmos and let it tick. Every effect had a cause, every action a reaction. To Newton, predictability was perfection. Einstein, however, saw elegance in the invisible. He believed reality was governed by symmetry, beauty, and logic, even if it defied our senses. He used thought experiments. What if you chased a beam of light? What would you see inside a falling elevator? These questions led to answers that reshaped science. Newton deduced from the world. Einstein imagined beyond it.
T-minus 10, 9, 8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on a mission to build,
Newton's laws power
resupply,
rockets, build bridges, and steer satellites. He enabled the Enlightenment and the Industrial Revolution. Without Newton, there would be no engineers, no physics classrooms, no technological era. Einstein's ideas also changed the world. Without general relativity, GPS wouldn't work. It corrects for time differences caused by Earth's gravity. Without quantum mechanics, triggered by his 1905 paper, we wouldn't have computers, lasers, or semiconductors. Even the atomic bomb, though Einstein didn't build it, was rooted in E equals mc squared. Both men shaped the tools of our civilization. Newton was buried in Westminster Abbey, a place reserved for royalty. He was seen as the supreme intellect of his age. But he was reclusive, difficult, fierce in academic disputes. Einstein was warm, witty, and human. He advocated for peace, warned against nuclear weapons, and stood for civil rights. His wild hair, violin, and smile became symbols of genius. Einstein became the face of the 20th century. Newton, the mind that started the modern age. So, who changed physics more? Newton gave us laws. Einstein gave us questions. Newton built the framework. Einstein expanded the universe. Newton made physics useful. Einstein made it strange and more beautiful. But ultimately, they built upon each other. Einstein stood on Newton's shoulders, and from there, he saw the curvature of space and the mystery of time. Who changed physics more? That is up to you. Thanks for watching this deep dive into the minds that reshaped reality. If this journey sparked wonder, subscribe to history's greatest minds. Like, comment, and tell us, Newton or Einstein? Until next time, stay curious and never stop questioning.